Hi everybody, I miss you guys. Welcome to video lesson number 1. So we're mostly going to be reviewing what we talked about last class. I on the board have a picture of a sine wave and of a cosine wave. And those are both waves that go up and down. The big thing to remember is that sine is the one that starts in the middle and then heads up. And then cosine is the one that starts at its maximum. And that has to do with how angles behave. You know that at 0 degrees or at 0 radians, an angle has a cosine of 1. That's why cosine starts at sort of its highest level. But if you think about it, going from 0 degrees to 90 degrees, like if I go from 0 degrees all the way up to 90, my angles get taller, and that's why the sine graph gets bigger. So you want to remember, sine starts in the middle and heads up, cosine starts at the maximum. Okay, so both of these graphs wave up and down, and last class we talked about how there's some properties to describe the middle, like the average output around which they wave, sort of where the center of the graph is vertically, and then how far they go above and below, how much they stretch out from the middle. So equilibrium is the word we use for the average output. That's where the graphs sort of like wave around, where their vertical middle is. And so usually that's 0. Both of these graphs go above 0 and below 0, but 0 is the middle. So that's the equilibrium. And then amplitude is how far above and below the equilibrium you go. It measures sort of how much you stretch away from the middle. So that's usually 1, because these graphs can get as much as 1 above and as much as 1 below. But what we were talking about last class is that there's ways to change that. That actually, if you shift your whole graph up vertically, that lifts up your equilibrium. A vertical shift creates a new equilibrium. And if you stretch your graph out vertically, if you stretch it out vertically, that gives you a new amplitude. And so what we're going to be doing today is we're going to be doing some practice problems where I have sines and cosines, where I've maybe shifted them up or down, changing the equilibrium, and I've maybe stretched them out, changing their amplitude. So as our first example today, I'm going to suggest that we should try to graph the function y is equal to 4 times the sine of x plus 6. So if you think about what you learned earlier this year, this graph has a vertical stretch. That means that every single point is going to be stretched 4 times away from the middle. So like those points that were 1 up are going to be 4 up. Those points that were 1 down are going to be 4 down. It's stretched out 4 times vertically. And then also it has a vertical shift up 6. So the whole graph moves up 6 units. In terms of our new vocabulary, this number here is our new equilibrium. I can say this graph has an equilibrium line. The middle of the graph is at y equals 6. And the amplitude of the graph, the amount that you stretch away from that, is 4. So here's what I'm going to do. I'm going to set up a graph that is centered at y equals 6 and goes 4 above that and 4 below that. So I'm going to draw my xy axes here. And it's okay if you're just sort of eyeballing it, but I want to draw a line at y equals 6 because that's where the middle of my graph is going to be, because the whole graph has moved up 6. So instead of having a middle at 0, this one has a middle at 6. And so I usually draw just a little dotted line there. So y equals 6 is the middle of my graph. And if the amplitude is 4, that means I can go 4 above that and 4 below that. So for instance, I'm just going to add 4 to say, okay, now my maximum is 4 above 6. Now my maximum is at 10. And I'm also going to go 4 below that. 6 minus 4 is 2. Now my minimum is at 2. So I want to draw a graph that instead of going up and down between -1 and +1, is going up and down between 2 and 10. The middle is at 6. You go 4 above to 10, 4 below to 2. The only other thing you have to think about is whether it's a sine wave or a cosine wave. So this is a sine wave, and that means no matter how much I stretch it out or shift it, it's always going to start in the middle and head up. So I'm going to look at this graph and I'm going to say I want to start in the middle. I want to start at equilibrium. And then just like there's like 4 quadrants to a circle, like 1, 2, 3, 4, you want to have 4 special points on your graph. So I start at the middle and I head up. That's my maximum. That's at pi over 2 or 90 degrees. I go back to the middle. That's at pi. I go down to the bottom. That's at 3 pi over 2. And then I go back to the middle. That closes out a full circle at 2 pi. 4 special points for the 4 quadrants. And because coterminal angles will make this go over and over and over again, I'm going to put an arrow on this side and an arrow on this side. And so that is a graph of 4 sine x plus 6. And I might also ask you about some properties of that. So if you had drawn this and I asked you to write out the domain and the range, it's actually really easy because since these graphs repeat themselves over and over and over again because of coterminal angles, it turns out the domain, the x's that are allowed in, if you went from the left to the right, is that this graph can take anything. Any angle is allowed. So the way I usually write that is x, e, r. X is an element of the set of real numbers. That means any angle at all is allowed to go into this. And then the range, what you might remember from both last year and a little bit this year, is that range is always measured from bottom to top. So it's what y's can possibly come out. I'm just going to say, what's my lowest y? That's 2. What's my highest y? That's 10. So I identified the equilibrium, identified the amplitude, gave myself a middle, made a top, made a bottom, started in the middle, and headed up. Okay, we're going to do another problem like that. So I'm going to erase this one. And so I'm going to have us try to graph now y equals 3 times the cosine of x minus 10. If you're feeling really good, you might want to pause the video and just try to do this one yourself. So what I'm going to do is, just like I did last time, identify the equilibrium, identify the amplitude, and then draw myself a middle, a top, and a bottom. So vertical shift gives me the equilibrium. This one has an equilibrium at y equals negative 10, because the whole thing moved down 10. And then the amplitude, the vertical stretch, is equal to 3. So if I want to start drawing this graph, I'm going to draw myself my x and y axes. And I'm just going to sort of say, okay, let's call this line right here a y value of negative 10. I want to stretch 3 above that and 3 below that. So if I do negative 10 plus 3, that makes me a maximum of negative 7. And if I do negative 10 minus 3, that gives me a minimum of minus 13. So I want a graph that's going to go up and down between those two values. The only thing to pay attention to is it sine or is it cosine? This one's cosine, which means I start at my maximum. So my highest possible point here is at negative 7. And then just like I have 4 quadrants, I do 4 special points. 1 to the middle, it's pi over 2. 1 to the bottom, that's pi. 1 back to the middle, that's 3 pi over 2. Close out the full cycle at 2 pi. And I'll put some arrows on it, but that's the basic idea. And if I again asked you for the domain and for the range, always really easy with these graphs. What's the domain? Everything. You can take the cosine of every angle ever, because we have positive angles, negative angles, coterminal angles. Every angle, you can take its cosine. So that's always going to be x is an element of the set of real numbers for sinusoids. You can take the sine or cosine of anything. And then range is always bottom to top. So I said my lowest y was negative 13. My highest y was negative 7. Boom, I'm done. Your homework is going to have just one other type of question. So I'm going to show you guys an example of that now. About half the homework is graphing, and half of it is going to be me giving you a description, and you try to draw a graph that meets the description. So, for a problem like that, what you might see is that I'd say that I really want you to create a graph that has this range. So I would say, how can you make me a graph with a range of 3 to 11? 3 to 11. And I might also give you another tip where I would say, okay, I want this graph to start at equilibrium and go up. But I can sort of ignore that for now. So here's the deal with range. We're trying to draw a graph that goes between 3 and 11. You can even start your picture right away if that helps you. You could say, okay, my lowest point is at 3, my highest point is at 11. What you want to figure out is where the equilibrium is. That's really easy. Equilibrium is the average output. So it's just whatever's exactly in the middle of your 2 points. What might be helpful is you just average those two numbers. So I could say, what is the average of 11 and 3? I'm going to add them together and divide by 2. 11 and 3 add up to 14. 14 divided by 2 is 7. That means 7 is the average. 7's in the middle. So if I draw 7 right here, I'll see 7 is 4 above 3, and 7 is 4 below 11. The fact that it's in the middle is what makes it the equilibrium. And if I draw a graph that starts at equilibrium and goes up from there, 1, 2, 3, 4, I have a graph that I can write the equation of. So I know that the amplitude is 4, because I went 4 above and 4 below the middle. I know it's a sine wave, because it starts at equilibrium. And I know that the equilibrium is 7, because that was the average. So putting all the pieces together, amplitude, the vertical stretch, is 4. It starts at equilibrium and heads up, so it's sine. And then the average output, the equilibrium, is 7. We'll do one more like that, and then we are done with this lesson for today. Boom! All right, bye-bye problem. Okay, last problem for today. Let's say I gave you a range that went from -10 to -6. And I said that I wanted the graph to start at the maximum point. So, just like last time, I'm going to start by drawing a little picture. So this graph only has negative output, so it's got a maximum of -6 and a minimum of -10. I want to find the equilibrium line between those. So as a reminder, the equilibrium line is your average output. And sometimes you can do that in your head. Like this one's actually pretty easy to do in your head. But you can also add the top and the bottom together and divide by 2. So if I were to do -6 plus -10, I'd get -16 divided by 2. The average output for this graph is -8. And that makes sense because -8 is 2 below -6 and 2 above -10. So my amplitude is clearly 2, and my equilibrium is clearly -8. Now the only other thing I have to think about is they said the graph should start at its maximum. So I'm going to start at the max. 1, 2, 3, 4 important points in a full circle. And if I want to write the equation, I know this is cosine because it starts at maximum. So I'm going to say that the equation of this is amplitude, vertical stretch of 2, starts at its maximum, so cosine, and vertical shift, equilibrium of -8. Boom. I think you guys are all set for the homework. Best of luck, and I will look forward to seeing you in office hours if you have any questions.